With an estimated 3.6 million US patients currently using medical cannabis, now legal in 35 states, to help conditions such as chronic pain, fibromyalgia, and multiple sclerosis, it begs the question of whether the drug may also be helpful toward another health condition that is the second leading cause of preventable death in the United States behind smoking yearly: obesity. Of course, at first thought this may sound like a senseless proposition, given the so-called munchies effect that comes with cannabis use. But interestingly, emerging research is showing otherwise. So today we'll be getting into it. Just please note that we are not encouraging its use to aid weight loss outcomes, only exploring the current theories laid out by the researchers as to how medical cannabis could potentially aid obesity down the line. And as always, please take note of our disclaimer. Cannabis is thought to have been around for millennia, with some researchers believing it was used in what is now known as Romania over 5,000 years ago. In fact, there is some evidence that women used cannabis medicinally to make the process of childbirth easier in 400 AD. There are three primary strains: sativa, indica, and ruderalis. The difference between them is their proportions of the two main phytocannabinoids, THC and CBD. What further differentiates these phytocannabinoids from each other are their contrasting chemical arrangement, psychoactive components, benefits, and side effects. While THC is responsible for the famous high sensation associated with cannabis, CBD is considered a non-psychoactive compound, meaning that you won't receive this high from CBD alone. To understand how medical cannabis may help obesity, we need to discuss the endocannabinoid system. This is a biological network consisting of endocannabinoids, receptors, and enzymes. Endocannabinoids are molecules made in the body, the two main of which are AEA and 2AG. These molecules bind to the two principal endocannabinoid receptors, CB1 and CB2, to help maintain essential bodily processes. CB1 receptors affect mood, cognition, pain, inflammation, nausea, and appetite. In contrast, CB2 receptors function in immune modulation and mediation of inflammation, as well as being involved in the maintenance of bone density. Another main difference between them are their whereabouts. CB1, for example, is primarily located in the central nervous system, so your brain and spinal cord. CB2, on the other hand, is found mainly in immune cells elsewhere in the body. Accordingly, the variance between CB1 and CB2 functions really doesn't come as a surprise given where they're mostly located. Now, in people with obesity, these CB1 receptors are upregulated, meaning their functions are in a state of overactivity. The reason for this isn't currently clear. However, it has been indicated to be due to diet, specifically the balance of dietary omega-6 to omega-3 fatty acids. In prehistoric times, when our ancestors were hunter-gatherers, it is estimated that their dietary omega-6 to omega-3 ratio was at most 3 to 1. This means that for every 300 milligrams of omega-6 fat that was consumed, they consumed 100 milligrams of omega-3 fats. However, in modern times, it's estimated that the ratio of these fats from a typical Western diet is as high as 20 to 1. Shocking, right? This disproportional ratio causes the levels of the endocannabinoids AEA and 2AG to go up, as omega-6 fatty acids are precursors for both, which leads to the CB1 receptors that they bind to being put into overdrive. This results in appetite increasing as well as the pleasurably reward from food, equaling more calories consumed over the course of a day. Apart from this, activation of the CB1 receptors is suggested to decrease the resting metabolic rate, increase the buildup of fat tissue, and cause cells to become more insulin resistant, which means that less glucose is able to enter our cells to be used as energy. Which then leads us to the question of how this relates to cannabis. Well, it's not just endocannabinoids made naturally by the body that can bind to the CB1 receptors. The THC content of cannabis does too, meaning that it can similarly impact appetite, lipogenesis, insulin resistance, and energy conservation. For appetite in particular, this is how the munchies effect associated with cannabis occurs, which is not just anecdotal but actually does have research supporting it. For instance, a study using 15 years of longitudinal data from over 3,600 adults found that more extensive marijuana use was linked to 619 more calories consumed per day on average. Research in the United States investigating the dietary intake and nutritional status of cannabis users versus non-cannabis users found that users consumed 564 more calories daily on average. And cannabis users were indicated to substantially increase their daily calorie intake by as much as 1,095 calories in a trial conducted in the United States. However, doesn't this mean then that medical cannabis would just make obese persons gain even more weight? Well, that's not what the long-term effects from the research seems to indicate. For example, a 2018 systematic review by Clark et al., including 9 studies, which assessed the BMI status of people who smoked cannabis against those who didn't over the long term, showed that the average overall BMI was actually 1.5 kilos per meter squared lower in cannabis populations. Now, you'd be right in thinking that these findings seem paradoxical. Yet evidence proposes that even though the THC content of cannabis leads to increased CB1 activity in the short term, and so worsened calorie consumption, long term it may lead to a suppression of CB1 activity by reducing the impact of enhanced AEA and 2-AG production, which arise from the elevated dietary omega-6 to omega-3 ratio, ultimately leading to improved calorie consumption and weight loss. By the same token, since THC stimulates CB1 activity in the short term, which decreases resting calorie expenditure, it's also theorized that CB1 suppression from long-term THC use may help improve the calories someone burns while resting that way too. On a side note, if you're interested in undertaking our evidence-based and results-backed personalized plateau weight management program, please click the link in the top right-hand corner of the video or follow the link in the description. Nevertheless, the potential advantages in managing obesity by suppressing the CB1 receptor isn't without its potential dangers. For instance, if you've ever heard of the weight loss drug rimonabant, it worked by doing exactly that. But the problem with rimonabant was that it did not just bring the activation of this receptor to baseline, but actually significantly below it. This led to its disapproval in the US and eventual removal from Europe because of incidences of depression and suicide, since, again, the CB1 receptor has functions on mood and cognition on top of appetite. Also, cannabis itself presents its own potential side effects, according to Page et al. In 2020, such as acutely and irregular and rapid heart rhythm, inadequate sleep, loss of short-term memory, bronchitis, a state of general sadness, dissatisfaction or frustration, anxiety and paranoia, and chronically an increased risk for psychosis and schizophrenia, especially for those already susceptible to these conditions. In light of this, when considering any new intervention to help manage obesity better, it is of the utmost importance that the potential risks don't heavily outweigh the potential benefits. Further, this only goes to show the importance of only going about weight management this way under stringent medical care. Interestingly though, Greenway and Kerwin in 2019 suggest that a potential solution to these associated problems of using cannabis to help obesity could be by using a metabolite of THC, THCV, instead, since it doesn't suppress the reward or mood pathways in the brain like rimonabant, not psychoactive like THC, and there has been some positive findings on its use for body-weight in mice. For the same reasons, another safer alternative than THC for weight management may come through the use of CBD. Initial research suggests it may also reduce food intake and boost metabolism in different ways than seen with THC. However, most studies into the weight loss effects of THCV or CBD have only been conducted on animals, so more research on human trials needs to be carried out to warrant the use for either in the treatment of obesity. What are your thoughts on this? We'd love to hear from you in the comments section down below. Additionally, if you're new here, make sure to like and subscribe to our channel. So that has been our video. Thanks for watching, and I'll see you next time.